Hi, in this video we will see what is meant by partial fractions. Alright, so let's start with an example. Let's say we are given two algebraic fractions. The first one is 1 over x minus 1 and the other is 1 over 2x plus 1, and we want to add this. So as in normal fractions we take the LCM of the denominator first. We'll try to do that. Alright, so what do you get if you take the LCM? You can say the common denominator comes out to be x minus 1 times 2x plus 1, and in order to make this common denominator to the first fraction, you need to multiply 2x plus 1 in both numerator and denominator. Alright, so you end up getting 2x plus 1 plus x minus 1. As the second term doesn't have x minus 1, you have to multiply x minus 1 in both numerator and denominator. You end up getting this as the result. And if you further simplify, you say it ends up to 3x over 2x square minus x minus 1. So the addition of these two algebraic fractions is obtained as this. So if let's say we are given the end fraction and we want to find on addition of which two fractions do we get this end fraction, this process is known as decomposing a given fraction into partial fractions or components. So let's say we have 8x plus 7 over x square plus x minus 2, and we need to find out what is the sum of two independent fractions which gives you this. So we can do this in this form. Let's say the first point we need to do is we need to factorize x square plus x minus 2. So you will end up getting x minus 2 and x plus 2 and x minus 1. So we can write it as a over x plus 2 and b over x minus 1. So the process of writing this in this form is splitting the fractions into the component fractions. So a over x plus 2 is considered as one component and b over x minus 1 is considered as the other component, right? So component is known as the part of the whole, right? So this splitting we call it as partial fraction decomposition, and it has lot of applications in solving problems involving integration and finding the sum of a series. Alright, so let's start solving this. As we have seen, the denominator can be splitted as two linear factors, that is x plus 2 and x minus 1. So you end up getting the initial step will be considering a over x plus 2 and b over x minus 1. Alright, now if we take the LCM of this two, we end up getting a times x minus 1 plus b times x plus 2 over x plus 2 times x minus 1. By its show, you will say as the LCM is x plus 2 times x minus 1, you need to multiply x minus 1 in both numerator and denominator in the first case, and x plus 2 and x plus 2 in the denominator and numerator of the second component. So thus you will get a common denominator and the numerator is in this form. So if you compare the first fraction and the last what we have got, you can say you can equate this two, and looking at this you can say you can cancel off the denominator as they are same. Alright, now you can equate the numerators. So when you equate the numerators and write it in the form of some term times x plus a constant term, you obtain this, right? And further doing, you get the component of x or the coefficient of x as a plus b, and the constant term will be minus a plus 2b. Now using the equality of two polynomials, you can say the respective coefficients and the constant term should be equal. So you end up getting equations of the form a plus b equals 8 from the coefficient of x, and from the constant term minus a plus 2b equals 7. Alright, and now if we solve this two simultaneously, you end up getting the value of b as 5, and if you substitute it in the first equation or the second equation, you will get the value of a as 3. Alright, so our process is done. So we can say 8x plus 7 over x square plus x minus 2 is nothing but the sum of 3 over x plus 2, 3 is nothing but the value of a, plus 5 over x minus 1, 5 is the value of b. So this is known as partial fraction decomposition. So given a complicated fraction, you need to find out the components in these form. So this process is known as partial fraction. Alright, so let's understand what type of fractions can be converted into partial fractions. So we will look into algebraic fractions. So here we have the first one. We will define it into two categories. Let's say the first is the proper fraction. So you can say when the degree of the variable in the numerator is less than the degree of the denominator, you say it's a proper rational fraction, right? For example, you can say 3x over 2x square minus x minus 1. So here the degree of the numerator is 1 and the degree of the denominator is 2. So you can say the degree of the numerator is less than the degree of the denominator. So it's a proper rational fraction. So we can convert this into partial fractions easily. And the other category will be improper rational fractions, that we say when the degree of the numerator is either greater than or equal to the degree of the denominator. Alright, for example, you can say if the degree of the numerator and denominator is same over here, this is improper rational fractions. And in the second case, you can see x cube and x square. So the highest degree of the numerator is greater than the degree of the denominator. So these are improper rational fractions. So over here, what we can conclude? We can say proper fractions can only be decomposed into partial fractions. So it's easy to decompose a proper fraction into partial fractions. Whereas if we are given an improper fraction, then what we should do? Then you can say that the improper fraction has to be converted into proper fraction, and then only it should be split into partial fraction. So we will look into some examples how to convert it into a proper fraction if you have an improper fraction, and then convert it into partial fractions. Alright, so just before going into that, we will see some standard forms of proper rational fractions and what will be their corresponding partial fractions. Alright, so forms I'll make in the form of a table. Let's say the first case is you have two linear factors in the denominator, and the numerator you have a linear term. So the denominator becomes x square and the numerator is x to the power 1. So it's a proper fraction. And the thing to note over here, this form works when the two linear factors in the denominator are not same. So we state a is not equal to b. So the respective partial fraction will be of the form a over x minus 1 plus b over x minus b. So you can solve using the variables a and b. The values of a and b are to be solved using the simultaneous equation. Alright, the second form, when we say the linear factors in the denominator are same, so that can be expressed as x minus a whole square. In that case, you should take the partial fraction in the form a over x minus a plus b over x minus a whole square. If we move to the third, let's say you are given a quadratic in the numerator and three linear factors in the denominator. Still, it's a proper rational fraction. So the respective partial fraction can be solved using a over x minus a plus b over x minus b plus c over x minus c. Alright, let's move to the next. Let's say you are given one linear factor is repeating and the other linear factor has degree 1, and in the numerator you have a quadratic expression. Then the respective can be considered as the combination of the first and the second rule. Alright, so it will be a over x minus a, b over x minus a whole square plus c over x minus b. And the last form, let's say you are given a quadratic expression in the numerator and you have a linear factor as well as there is a quadratic expression in the denominator. And we have taken this as a quadratic expression, and how it's different from the fourth law, let me state. Let's say you are not able to solve x square minus plus bx plus c in the form of two linear factors. In that case, you should take the partial fraction of the form a over x minus a plus bx plus c over x square plus bx plus c. Alright, using these forms, we will solve the questions. So our objective over here is writing a given rational fraction in these form of partial fractions, and we will be calculating the values of a, b and c. So these are the real numbers which we need to determine. Alright, so let's start here with an example. Over here you have been given 1 over x plus 2 times x plus 1. As you can say, the degree of the numerator is less than the degree of the denominator. You can write this as the partial fraction of the form a over x plus 2 plus b over x plus 1. So a and b value are to be determined. So in order to do that, what we can do over here, we can cross multiply and take the denominator as a common term. I can write this as x plus 1 times x plus 2, and in the numerator you have a times x plus 1 plus b times x plus 2. Right? Now you have the common denominator. We can say the denominator and this will get cancelled. Alright? So the numerator, you will say 1 can be equated to, if I take the coefficients of x term, you can write it as a plus b times x plus a plus 2b. Now if you see here, the left hand side can be written as 0 times x, as you don't have any x terms. Alright, so if you do that, now you can apply the equality of polynomials. Alright, so what does it state? The coefficient of the respective powers of x should be equal and the constant term should be equal. So you can say you obtain a plus b equals 0. This can be your first equation, and the second equation will be a plus 2b equals 1. Alright, now if we solve these two equations, let's say if we subtract these two equations, what do you obtain? You can say you obtain minus b equals minus 1, as a and a will get cancelled. Alright, and you obtain b equals 1. Now if you substitute b equals 1 in first equation or the second equation, let's substitute in the first equation, you obtain the value of a as 0 minus 1, that gives you minus 1. Alright, so you can write 1 over x plus 2 times x plus 1 can be written as minus 1. So you should be careful over here, as you are using a, you have the denominator as x plus 2, so it will be minus 1 divided by x plus 2 plus 1 over x plus 1. So you say the partial fraction form of the given expression is this. Alright, let's see one more example. So over here you have the numerator as minus x square plus 11x minus 10, and the denominator is x cube plus 3x square plus 4x plus 12. Alright, so the first thing you need to check is whether the given fraction is proper rational fraction or improper. As you can see, the degree of x is less than degree of x in the denominator, right? So the numerator degree is less than the denominator degree, so it's proper. But in all the forms that we have in standard, we are having the linear factors in the denominator. So let's start solving for the denominator here. So you can say x cube plus 3x square plus 4x plus 12. If you see from the first two terms and the next two terms, if I make pairs, you can take x square common from the first term, you obtain x plus 3 plus 4 on the next two terms, so you get x plus 3. So this can be written as x plus 3 times x square plus 4. So the given question can be framed as minus x square plus 11x minus 10 whole divided by x plus 3 times x square plus 4. As x square plus 4 can't be splitted into two real factors, right? What do? We keep it as a quadratic form, and this comes under the fifth form if you see in the table. So we can write this will be equivalent to a constant over the linear factor, that is x plus 3, plus a linear factor, that is bx plus c over x square plus 4. So always you remember, over here you are taking a linear factor over a quadratic. When you have a linear, you take a constant. So if you try solving this, what do you obtain? You can say a times x square plus 4 plus bx plus c times x plus 3 whole divided by x plus 3 times x square plus 4. Alright, so you can see now the denominator in both these cases are same, so you can just remove it and compare the numerators. So let's try doing that. So you can say minus x square plus 11x minus 10 will be equal to a times x square plus 4 plus bx plus c times x plus 3. So if you open up the brackets, you get ax square plus 4a plus bx square plus cx plus 3bx plus 3c. And if you make it in the pairs of x square, x and constant, you will obtain a plus b times x square plus 3b plus c times x plus 4a plus 3c. Alright, now if you compare the given polynomial with this expression, you obtain the equations, the equality of the polynomials. You obtain a plus b will be equal to minus 1, 3b plus c will be equal to 11, and 4a plus 3c you obtain it as minus 10. Alright, now if you try solving this, you will end up getting the value of b as 3, right? You can solve taking 2, and like for example, let's say if I solve first and the second one, you can eliminate the variable b, you get an equation in terms of a and c, and that equation can be solved using the third equation. So you obtain the value of either of a and c from this, and then substituting back in first, you get the value of b. So you'll obtain the value of b as 3, a as minus 4, and c as 2. Alright, and if we write it, you can say this equation can be now written as, over here we can just substitute it in this place. So let's write the final thing over here. So you obtain minus 4 over x plus 3 plus 3x plus 2 over x square plus 4. So you obtain this as your final answer. Alright, now let's take one more example that is based on the improper fraction. So let's say you are having the same degree. Alright, so it becomes easier when you have the same degree and the coefficients of both the highest degree are same. So what can you do over here in order to convert it into proper fractions? Let's say we will write the complete denominator over here. So x square minus 5x plus 6. So what we have done, we have subtracted 5x and added 6. So we will add 5x again in the numerator and subtract 6 and keep the 1 as it is. Okay, so the x square has been used up here and the 1 of the numerator has been added. Alright, so now what we can do, divide the complete thing by x square minus 5x plus 6. Alright, now you can make this fraction as pair of first 3 terms and the next 3 terms. So you get this as x square minus 5x plus 6 over x square minus 5x plus 6 plus this can be reduced to 5x minus 5 over x square minus 5x plus 6. So as you can see, you can cancel off this and just write it as 1 plus 5x minus 5 over x square minus 5x plus 6. So this is now your proper rational fraction and you will keep 1 as it is. Okay, so now our objective is to solve this. So let's do it. So 5x minus 5 over, as we have seen, the denominator has to be in linear factor form if it's possible. So if you try doing this, you can say you can split minus 5x as minus 3x and minus 2x. So the product will give you 6x square and the sum will give you minus 5x. So you can obtain the linear factors as x minus 3 and x minus 2. Alright, so as you can see, this comes under the first type. So you can write this as a over x minus 3 plus b over x minus 2. And if you simplify it, you can say you obtained a times x minus 2 plus b times x minus 3 whole divided by x minus 3 times x minus 2. Now the denominator are same. You can compare the numerators easily. So you write 5x minus 5, and if I multiply and keep the pairs of x and constant term, you get a plus b times x minus 2a. So let's write it as plus, in brackets we will write minus 2a minus 3b. So the constant term is minus 2a minus 3b, and this is equal to this. So now using the equality concept of polynomials, you can say a plus b will be equal to 5 and minus 2a minus 3b will be equal to minus 5. Alright, and if you solve these two simultaneously, you will obtain the value of a as minus 5 and you will obtain b as 10. Alright, so you can write the given expression as we have left over here. 1 will remain as it is, and this can be split into two terms that is considered over here in this form. So we'll substitute a and b in this. So you get 1 plus minus 5 over x minus 3 plus the value of b is 10, so it will be 10 over x minus 2. Alright, so if you write it in simple words, you have to just replace plus over minus as it gets multiplied. So you can write 1 minus 5 over x minus 3 plus 10 over x minus 2. Alright, hope you like this video and the concept is clear to you. Please do subscribe to my channel to stay updated on the upcoming videos on different interesting topics in maths. Thanks for joining.